The topic is scalars and vectors. So I believe at one time or the other you must have wondered what scalars and vector quantities are and how to resolve them. Scalars are numerical quantities. They are physical quantities that have magnitude alone but no direction. Vectors, on the other hand, are simple quantities that have both magnitude or numerical size as well as direction. So, what are the examples of scalar quantities now and vector quantities? Scalar quantity will talk about mass, length, temperature, time, temperature gradient, volume. Vector quantities will talk about force, weight, gravitational field intensity, electric field intensity, magnetic field intensity, just name it. Then, how do we represent a vector? To represent a vector, you use a straight line with a arrow in front, where the arrow represents the head and the opposite side represents the tail, and the size of the line represents the magnitude. So the angle between the vector as well represents the direction. For example, the velocity of a bolt displaced at an angle to the horizontal is represented by the image you can see, where theta represents the direction and the straight line represents the magnitude of the resultant displacement. You can see an arrowhead to show the direction. Of course, it's represented by two coordinate systems, the y and the x coordinate system. So addition of vectors. Addition of vectors simply involves geometric algebra. When two vectors are in the same direction, the angle between them is 0 degree, and the resultant vector can be calculated by simple addition. Here, the resultant can have the highest magnitude as we are just adding up. Please take note. Same direction, we add up. So, what do we mean? Here's a simple illustration for us to understand better. We have two vectors, 100 Newton and 150 Newton, acting in the same direction and also acting in opposite direction. You can see the same direction we just added to get 250 Newton, and in opposite direction we subtracted. So let's look at vector components for an object on a slope. For instance, by slope we mean an inclined plane. So how do we resolve vector components? Components of a vector simply means analyzing the resultant vector in two particular directions, the x and the y components. So, for instance, we are given a question to resolve a vector. As you can see on the screen, here is an inclined plane, a body on an inclined plane, and when you resolve, you have along the parallel to the plane, we have w sine theta, and perpendicular to the plane, we have w cos theta. So, w sine theta is the component that is parallel to the plane when you use your SOHCAHTOA. So when you can find the force as well as the acceleration of a body when you are asked, as you can see with this example. So you may be told to find the force as well as the acceleration of any given or of a body. So this is how to go about it. Remember, W is equals to mg sine theta. So when you resolve this question says the component of the weight parallel to the slope. So take notes. So resolution of two vectors acting at 90 degrees. By now you should become conversant to the Pythagoras theorem. The Pythagoras theorem. When two vectors are perpendicular to each other, the angle between them is 90 degrees. Use the Pythagoras theorem to find the magnitude of the resultant vector. And how do we find the direction? You simply use tan theta, which is what? Opposite over what? Adjacent. So that's how to find the resultant vector when two vectors are perpendicular to each other or at right angles or 90 degrees. So please take notes. We use the Pythagoras theorem. So that is